Great. So we're on. All right. So I'm going to go through the purpose of this series of courses that we're going to do. I'm going to go through the syllabus, and I'm going to go through just general Google Classroom for those of you all who I don't think at this point anybody is not familiar with it. But just a little navigation of the Google Classroom, and then we will start, right? So good. So inside of the Google Classroom, we have some areas here. We have stream. This is where you get a chronological view of everything that's going on in the classroom. I hope that some of you all read from beginning to end. Okay. At the start of the stream, you could see where I posted some of the resources earlier on in setup for the class. Under classwork, I've included a compiler. We won't be starting programming for about 2 or 3 weeks, or probably, for about 2 or 3 weeks. I posted cprogramming.com's tutorial. I think that this is an excellent site with some fairly easy to follow tutorials that allow for you to practice along when we do start programming in C. And of course, this course is not going to go all the way through the syllabus. It's going to just go to essentially arrays and iteration. Okay, but the purpose of this course is to give a nice foundation level knowledge of what is happening. And I mean, I'm offering these Monday sessions for an opportunity for students who who need who have a question or something so to ask. Maybe at the end of every session we could interact a little bit, and I could address some of the issues you have and the gaps in your knowledge, etc. Right? Let me officially introduce myself. My name is Johannes Valdez. I've been teaching computer science at Cape level for just over 15 years. I teach currently at the Bishop Anthony Trinity College East Sixth Form. So, I've been there for the duration of my teaching career. And, I'm passionate about having people learn, especially programming. And I know that a lot of students struggle with programming, struggle with computer science, especially the programming part. I've corrected CAPE examinations. I've seen it myself firsthand, where students have difficulties with the programming, with the issues, etc. So, I've decided, especially since we've started late in the pandemic, to do this to allow students to have a little extra supplemental. This is not meant to be a course that you could get everything out of. It's designed to essentially just reinforce what you're going to be learning in school or what you are learning in school, right? It is hopefully we can speak, you can ask questions. Feel free to I'll post up a section where if you have a question, like a little question corner, you could post that question if you say you could want to get it addressed in class, or if you just want to answer on the fly as to why something works. Me and the person assisting me with this course, we'll take a look at it and we'll try best to explain it to you. Okay? At some point in this course as well, we're going to do some simultaneous learning C programming and learning flowcharts and pseudocode because of the short time frame that we have, but hopefully we can get in something that's really useful, Okay, so we have the schedule of topics. This is what we are going to, this is the hope in terms of what we're going to cover. I hope that you all have gone through this. All right, so this week we're just taking an introduction. We're looking at the syllabus because it's important for us to know the syllabus. A I'll talk a little bit about what your SBA might require as well when we look at the syllabus. Well, this is the course review. We're starting off simple with just an understanding of variables and operators, data types, and truth tables. So that's our goal for today, to be able to talk about what are variables, what are operators, what are data types, what are truth tables. We're going to generate some notes. While we are going along, and the notes will also be posted to the Google Classroom. So once you're inside the Google Classroom, the goal is that you'll have access to the videos of these classes. You'll have access to the work that we do, the explanations. And if it is that we can, I always try, especially coming down to the latter weeks, I'll try and see if we could squeeze in one or two past paper questions to just kind of, look and see if you can gauge yourself as to how ready you are to do the exam. Though the exam is far away, so we're not worrying about that. Okay, our focus here is on understanding. All right, so this is for week 1, right? Week 2, we're into control constructs. We're going to talk about selection and sequence. We're going to introduce flowcharts and pseudocode algorithms. We're going to continue with a further control construct in week 3, bounded and unbounded iteration. We're going to do more flowcharts and pseudocode algorithms. Then we're going to take a look into C programming. We may be able to start C programming in week 3, at the end of week 3, right? We're going to have an introduction to C programming. We're going to take a look at some variables, input, output, sequence, pseudocode, program development from some questions that we'll look at, right? So we want to start to develop things in C. Then we want to move to looking at iteration in C, and of course arrays and strings in C. So I'll go as slowly as I could, but we have to be mindful of the time constraints. Every Monday at this time till 7 o'clock my time, right? So we'll do an hour and a half. Sometimes we might go over a little bit. That's fine, right? But we'll always have at least an hour and a half of live session where we learn something, and we really and truly want to just get some practice in. Okay. Then we'll go, right. So we've talked about the structure of the course. Let's take a look at the syllabus. It's really important to understand and know the syllabus going into your course of study. We have this. The syllabus here is a new syllabus. This is the syllabus from that CXC will be focused on next year, right? You could download the syllabus off of CXC's website. I've posted it to the Google Classroom here for ease of access for you as well. But we want to understand what CXC is asking of us as we take a look at moving towards exams next year. Okay, so this is the syllabus. We are doing Unit 1. Unit 1 is split into 3 modules: computer architecture. I'll talk about it now, but we're not going into computer architecture. No learning about computer architecture except for truth tables, which I think is fundamental in understanding programming. So that we're going to be doing that today, right? We have problem solving with computers, which is pseudocode algorithms, essentially understanding how the problem-solving process works. We'll be focusing on that all throughout the next couple of weeks. And then we have programming, which we'll also be focusing on within the next couple of weeks, up until we reach to arrays, okay, iteration and arrays. Now, in the problem solving with computers, we are practically doing most of that module, and we'll be doing about what I would consider to be about half of the programming module for this topic. But I always say, as long as you get these base concepts in, you're going to be fine with the later concepts, the more difficult concepts to understand, like structs and file manipulation. Those concepts are going to be easy to understand as long as you have a good grasp of the problem solving with computers and the programming concepts. Anybody have any questions so far? Again, if you have any questions, you could always communicate it in the chat, or you can just use the raise hand button, and I'll hear a little ping and I'll answer your question. Okay. Right. So we have data structures, software engineering, operating systems and computer networks, but that's next year, right? Let's not worry about anything to do with next year. So we're going to jump to, oh, my document didn't load properly. Let me see if I have it. Oh, okay, so it's loading. Right. So for the fundamentals of computer science, the Unit 1, Module 1, okay, we want to be able to, this is stuff that we're not going to do here, but we're just looking at it. We want to understand the components of a computer system. So your teacher will talk to you about hardware concepts, things like input, output, specialized devices, ROM, RAM, EEPROM. Some of that you would have met in CSEC, correct? And then you would have had we will talk about storage devices and features of components of the computer system, like width, size, speed. We'll talk about things to protect the computer, like UPSs, etc. This section here, this section 2 here is what we're going to. This section 2 here is what we're going to speak about in terms of today. Right, I'm not going to go into the more complex one like NAND nor exclusive or and exclusive AND, but we could talk about those later on. Right, the things that you have to know is the AND or and not. We have registers, counters, all of those additional circuitry. Your teacher is going to go through them. We have the basic building blocks, the logic gates, the data flip-flops. Again, we're not covering these. We're looking at binary representation. I think that this is important. I might do a little bit of this. I could probably do it today if we have the time. Okay, at least to be able to understand how to move numbers between base 10 and base 2, and then we also have understanding the characteristics of a processor. So out of this, we'll be mostly talking about the truth tables, some of the logic gates, and we're not even drawing the logic gates. We're just talking about the logic gates as it relates to truth tables. And then we will talk today about the data representation, some binary, etc. Right? Good. So next up, we have Module 2. Module 2 is has to do with problem solving. We have understanding what problem solving is, different problem solving methods. I'm not going to go too much into the theory of that. We have stages in the problem solving process. We have different ways of representing algorithms. We have programming constructs, which are the selection, sequence, and iteration. We have the input and output statements that we need to look at. We have where we error check programs, and we understand how to approach a program given a particular problem. And then we have where you check an algorithm, you look at the actual pseudocode and you test it yourself using like a trace table, or trace table to essentially verify the output. Okay, so this is all about algorithms. The second section, it's quite simple. It's nice. It calls for some logical thinking. So if you're not very good at logical thinking, we're here to learn how to think logically and how to think step by step. Okay, and lastly, we have the programming section, And the programming section in the syllabus starts off by taking a look at different programming paradigms. We have the different stages in program translation. We're not going to talk about that in detail, not now, maybe in the future, we don't know, right? But you should cover that in class. We're going to take a look more towards the programming stuff like declaring variables, inputting data into variables. We have different conditional statements, which is selection in programming itself. We have arrays. We have iterative constructs, and while statements as well. We want to be able to do functions. I don't think I'll be able to get to functions with you all as well. So this is it's up to here that we will go up to this section 6 here. But really and truly, if we get the chance, I will try to show you some of how functions work. We will be testing and debugging programs by default, because once we start to do simple programs, we're going to test them in different ways. Okay, so we're going to do some error checking. There's something called structs in C. Those are records, right? They're like advanced arrays, basically. We have file operations. We're not going to be dealing with that. But I will be inadvertently teaching you good programming style. When we do programs, I like to document one time as I write the program. So everything that we write together, we're going to document. We're going to look at how to space your programs, how to have your programs readable. I am a stickler for proper spacing. So certain things, there are different programming styles out there. I'm just teaching you my style. You might see another style that's very popular. You might like it. But what we don't want is an unacceptable style. Okay? And then, of course, we have variable declarations in other languages. Your teacher is going to teach you that. That's just basics of some of the other popular languages as well. And we need to be able to justify the need for different programming languages. So that is essentially what we are hoping to do over the next year as computer science students. But what we're going to do here is about 40% of that unit 1 in the next couple of weeks, right? And it's the core concepts that constitute that. So I'll be just generating some notes. We'll be talking about it. Everybody's fine with that. If you're good with that, put your hand up. If you regret selecting computer science and you want out at this point, well, maybe you have to talk to your school and talk to your teacher and let them know. So everybody's good. Everybody's good so far. Now I have a dual screen, so most of the time I put up my conference window on my second screen, and I look this way. You'll see me kind of looking to the side here. I'm not going mad and looking at somebody, on the far side. I'm actually just dealing with my other screen where I have people, right? That hand that's still raised, is that just in response to my last question, or you have another question that you're going to ask?
That was just in response to the last question.
Oh, you're coming in a bit broken up. Oh, yeah, no, it's just all right. So we're moving on to business. So let me start. Okay, I heard like if somebody was talking, nobody's talking, maybe I'm going crazy. Right? All right, I talk to myself a whole lot because a lot of times students don't talk to me. So don't mind if I have little conversations with myself ever so often. I'm not going crazy. Computer science just does that to you. All right. But everybody's hearing me clearly, right? Can I hear one or two voices? Anybody could say yes, sir, no, sir. At least let me hear.
Yes, sir.
Is the connection
unstable? Yes, sir.
Yes, sir.
All right.
Yes,
So
sir.
I'm getting a bit of an echo from people. All right, so I'm going to type something in the chat.
Sir, hear you correctly, sir.
Okay. Okay, good. People are saying yes, they're hearing me, but I'm having a bit of a problem hearing most of you. So there might be a little issue with my internet coming in, but as I said, it was raining. Just allow me, I might drop out of the class for a second. I'm not going, I'm just switching to another network point, okay? One last attempt. Could anybody say something so just so that I can see if my connection is at a...
Yes, sir.
Okay, yeah, you're coming in nice and clear now. I don't know what was going on with my incoming audio, but it seems to be fixed now. All right. Okay, so we're going to start. We're going to start, and we're going to, as I said, we start. Our starting point basically is variables and operators. Okay, so just allow me a second. I'm to share my screen, my whiteboard, and then we are going to go. Oof. You know, computers, I always say computers are always out to embarrass you because at this point I'm trying to get my notes document open and it's not quite opening like I want it to. But just give me 1 second and I will get it open. All right. Okay. Just gonna have to take a different approach to getting it open. All right. So you could be messing around with your friends on the internet and things will go, you know, straight, no issues whatsoever. But as soon as you have a class going on and it's recorded, you know, the internet is always there to mess you up. All right, but I've gotten it to work, and we're going to move on from there. Okay, so we're gonna start off. I just want to start off with a little bit about problem solving. We have the all of, let's say, programming is based on problem solving, right? All of programming is based on problem solving. So once you have a problem to solve, you know, a program to write, sorry, you have a problem to solve. If it is that you don't have a problem to solve, then you wouldn't be able to really write a program for it. You can't really just, you know, write a program with no objective. There needs to be an objective for writing a program. So we want to talk a little bit about general problem solving, and there's a problem solving process that gets followed, right? And the first step towards problem solving is identifying a problem. Okay? And that ties in with what I just said. That if it is that you can't have a solution if you don't have a problem. Okay, that makes sense to everybody. So problem solving,
Yes, sir.
yeah, yes. So problem solving is rooted, right? Getting to the solution is based upon having a problem to solve. So, and if you can't identify your problem, then you could never get to the solution. Hi, yes, I see a hand raised. See a hand raised? No? Okay, right? So this is the first step in problem solving. And we're just going to go through problem solving pretty quickly. All right. So the second step in problem solving is to understand the problem. You have to be able to understand the problem. You have to know a little more about the problem to be able to solve a problem. If it is that you don't understand the problem, this is too much at the time to show as a note. All right. Sorry about dropping all that in front of you all. Okay, let's just take it chunk by chunk. And I'm not gonna read this out. You guys can read this on your own. I'm just basically talking about it. You have to understand what is involved in the problem before you could continue towards the solution. Does anyone here know what is going to happen if it is that you have a problem that you're trying to solve but you don't fully understand the problem? Anybody want to offer a solution, answer to that question?
You wouldn't be able to have a proper solution if you don't fully understand the problem.
Exactly. You're going to just solve part, right? So thanks very much. You're just going to solve part of the problem, or you might miss the core of the problem altogether. You have to know as much as possible about a problem before you can attempt to solve that problem, because you need to be able to work out the steps towards getting each and every intricate part of that problem untangled. You could think about a problem like a knot. If you just start pulling randomly to undo a knot, then you're probably going to make the knot worse. But if you look at the knot and you understand where one string leads to another string, or if you pull one string, if it tightens another string, then it's going to give you an idea of what you should pull and what you shouldn't pull in order to untangle the knot. Everybody is fine with that? Anybody have any questions so far? We good, right? Okay, good. Yeah. In these classes, yeah, good. So, everybody normally stays silent, and that means, hey, you say everything is fine. Then we have a couple more steps. The next thing that we do after we understand the problem is that we identify alternative ways to solve the problem. So you come up with all sorts of different solutions, and you could think them through. All right. I'm sure everybody here was playing with a ball already, and the ball gets stuck up in a tree, and you and your friends all of this stand up there watching the ball, and it's like, well, how are we gonna get our ball back? Some of your friends, the solution might be to take a stone and try and throw it and hit the ball and let the ball fall. Another person might say, hey, I have a mango picker in my yard. Let me go get that and chuck the ball and see if it will come out of the tree. Right? Another person, everybody have that wild friend who willing to climb the tree to get the ball. So these are alternative ways to solve your problem. And you come up with all the possible ways, and you could come up with the pros and the cons of that problem. So could I ask anybody here to tell me, well, what is a possible something that could go wrong with if you have a ball in the tree, if your friend decides to climb the tree to get it? Yes, Marco.
He could fall, sir, and
Well,
injure himself.
well, right. He could fall right out of the tree. So that's a possible problem. Okay. All right. So what's a possible problem with using a stone to get it out of the tree?
The
You
stone
get a
can ricochet, sir, and hit you back, sir.
exactly. It could hit your back, or you could have bad aim. You could miss the tree and you hit your neighbor house and break a window. Right? And if what was the possible side effect of using like a mango picker or a big stick to push the ball out of the tree?
So you might touch an electric wire, because sometimes the wire run in the trees.
Exactly. If the tree close to an electricity line, it could be dangerous. So, but Marco, I like that answer because that answer calls for an understanding of the problem. If the tree is close to, so that answer carries us back. That answer carries us back to part 2, where we understand the problem. If the ball is stuck in the tree and that tree is in the middle of a big field, and that field don't have any electricity lines around it, well, the big stick might be the best solution to the problem. But if the tree is close to the road where the line's running, what's the problem there? You could, you know, it might be better to use the stone or to use, you know, sometimes, you know, you could use another ball and try and hit it out of the tree. And, you know, sometimes if you use another ball and hit it out of the tree, both balls might get stuck in the tree. And then you're in more problems. You're in twice as bad problems. But it's
You could use a board, sir. A
you
board
could
stick.
use like a broad stick.
A board stick, sir.
Like what, to throw like a javelin or something, so?
Not really, sir, but like if it touches the wire, no current would flow through it, sir.
Like a wooden stick.
Yes, sir.
Yeah. No, I still afraid that. All right, I still afraid that. That's good thinking. Yeah, if you use a wooden stick, then it's less likely to conduct electricity. Okay, but I am very afraid of electricity. So, you know, you wouldn't catch me doing that anywhere, near any power lines or anything. So, but given the scenario and given the understanding of the problem, you have to select the best solution or the best way to solve the problem from the list of alternative solutions. So this one here, once you come up with your list, this here is based upon the previous 2. Selecting the best way to solve the problem is based upon the previous 2. Okay? And then lastly, we have we have 2 more inside of here. Once you select your potential solution, let me put this on another page. Once you select your potential solution, you want to list instructions that enable you to solve the problem using that solution. So, and let me go back and just annotate this and say this selection is based on your understanding of the solution. Okay, and forgive my bad handwriting. Okay, but the selection of the best way to solve it is based on the understanding, and the selection could adjust based on the understanding of the solution. That's why it's important to have as much information about the problem as possible. So once you do that, you list the instructions that enable you to solve the problem. So find a piece of a board or stick or whatever, and you have to ensure that the stick is a particular length. The stick can't be too much shorter than where the ball is in the tree. And or if it is that you go the route of finding something to pelt the ball in the tree, you have to get something that heavy enough to travel and knock it off when you pelt it, and pelt it there. So you put on your instructions, and this is something that we do every day. This here is something that we do every day without actually knowing it. Every day of our life, we go through this problem-solving process. Things like, what am I going to eat for breakfast? You go through the problem-solving process. Because if it is that you say to yourself, well, the first thing is identify the problem. The problem is I am hungry. I'm hungry. I want something to eat. Understand the problem. Well, I want something to eat, and I've woken up late and school starts online in 10 minutes. Okay, so based on your understanding of the problem now, that affects what goes on here. Well, I could make egg quick to make. I could heat up food from yesterday. Right? I could go without food, that's a solution. Or I could make some cereal. That calls for minimal effort. I think in this scenario, where I wake up late, I know I have 10 minutes and then my online class starts. I want to select the best way to solve the problem. The best way to solve the problem is to grab some cereal, throw it in a bowl, pour some milk over it, right? Because I hope we don't pour milk first like psychopaths. And, and eat that for breakfast, right? And then we say, so that was your instructions to enable you to solve the problem, and you evaluate the solution. Would this keep you until that class is finished and you could get something proper to eat? Or was it not enough food? Everybody's fine with that? Everybody good?
Yes, sir.
Yeah.
All right. So we understand the problem-solving process here. All right, so far. All right, so we talked about the problem-solving process. I'm going to jump forward a little bit. There's a little more that we could do exercise-wise and stuff like that, but I'm going to have to jump in because I want to get into understanding the actual algorithmic problem solving. Okay, so all right. So oops, I am right. So we want to talk now about some concepts regarding problem solving for computing. Because what we spoke about just now was like general problem solving. But now we want to talk about problem solving for computing. So we want to talk about naming and using variables, etc. Okay, so we're going to look at what are variables and constants. And let me put this on the screen so that at least we can know what our objectives are. Right? We want to take a look at knowing the difference between variable and constants. We'll take a look at the different data types that there are. We're going to take a look at operators, operands, and resultants. Okay? We're not going to talk too much right now about functions. So I'm actually going to highlight that in red and kind of take that off. And we want to understand the hierarchy of using operators. And then we want to evaluate some expressions, and we'll take a look at resolving some expression. So we're doing 5 out of these 6 things in a big way. Okay? We might have to implicitly just use functions, but I'm not going to go too much into functions itself. So what is a constant and what is a variable? That's a question to you all. Anybody can tell me what a constant is, what
Sir,
a
a
variable is.
variable is a placeholder,
Right? Yeah.
and a constant is a value that cannot be changed, sir. It's
All
like
right.
permanent.
Thank you. Okay, so like one of the really popular constants is pi. All right. Everybody here knows pi is always 3.14. Right? And the variable, if we have like a variable in terms of a circle, right? In terms of a circle, if we do in circles, we have a circle, and we know that we have r, and r is the radius of a circle. But we could have circles that are big, we could have circles that are small. R is always r. R is always r. But what happens is that according to the size of the circle, r is going to change. So a variable is essentially a named container. A variable is a named container for holding a value. Okay, so that's what we call a variable, right? A named container for holding a value. And in this case, example, r for the radius of a circle. And it's important because R allows us to essentially, hold 1 second, please. Right, thank you. So we have this container for holding a value. R is the radius of the circle, and R changes according to the size of the circle in this case. But what does not change is that mathematical constant. So we have the constant, and let me go back and, oh yeah, it's labeled variable, right? A constant in this case is a value that stays the same from the start of an algorithm to the end of an algorithm. And it essentially cannot change. Example, pi. And pi is always 3.14. Okay, so pi stays the same no matter what we do in terms of, good afternoon, in terms of, right? Marco, you might think, right? But then the law could change. Marco says VAT. The law could change, and then the value of VAT could change. So VAT, maybe in the instance of writing a program, you might think it might be safe to set VAT as a constant because it has not changed in so long. But then, you know, what if a political party comes into power and decides, well, I want to raise the taxes on goods. VAT is going to change, right? A couple of years ago, VAT fell from 15% to 12.5% here. If there were a programmer who, you know, considered VAT to be, well, you could set VAT as a constant, but you would change it in like the back end there as a, you know, have its reference value change. So yeah, you could consider VAT constant enough because it stays that way for long enough. But if it is that you're writing a program that might, according to territory, might change, you might have to allow them to set that VAT value in a way that it's easily changeable. Okay, so VAT is one that could totally line based upon territory. All right. So we have constants and variables. I just want to put a proper note here so that you all don't have to suffer through my handwriting when you're reading over you're reading over some notes. Okay, so here's a note on constants and variables, and it defines here what a constant is, and it defines also what a variable is. Okay, so we identify that the constant is that value that is, that never changes during the processing of all the instructions in a solution. And then we have the variable that may change during processing, right? And then there's also different names for variables, etc., as the programming languages change. But it's the purpose of a variable always it is what it is. So and constants and variables, that's something that we would have met in maths already. So I'm not going to stay too long on this as well. And I want to move on to data types. So we're going to talk now about data types. Anybody, before I move on from constants and variables, anybody had anything that they did not understand about constants and variables? Or is everybody comfortable with constants and variables as a concept? Okay, so both of them are named, but a constant is named and it stays the same. It always stays the same. Okay, and in maths we have a lot of constants that are that are popular. The most popular of all is like pi. Since I was small, pi is the same to what it is now. It was the same 1,000 years ago. And then we have values like x and y, etc. And those are variable values. Okay? So depending on the value of x, you could pass that variable to a function, and because that function does something, it'll show something on a graph or a line or something like that. So I see that nobody has put up their hand, so I'm going to move forward, and we're going to talk now about data types. All right, so we have data types, and data is manipulated by the computer, right? If we have to define data, data is something, a value that is unorganized. It's not yet processed. Okay, and once you put it in order, once you pass it through a computer system, it gets processed into information. Okay? So your computer, however, needs to know how to manage data that is passed into it. So what do data types do? We have data types, right? Data types. So what is the purpose of a data type? Marco?
So it like groups data into individual sections, sir?
Yes. So it's a way of classifying data. I like that. Right? Anybody else wants to share on what they think data types are?
Data types is like real, integer, Boolean, and stuff like that.
Yes. So that's like the names of data types, which we will see just now. Okay, but if we have to define it, a data type allows a computer system to know what operations, could be done on a piece of data. Okay, so the computer needs to be able to know how to handle data. And let me see if I can get somebody besides Ayana and Marco to answer a question. Do I have a volunteer? Any volunteers besides Marco and Ayana who's been doing a great job at keeping this nice and interactive? All right, so I see Gabriella has her hand up. Gabriella, how are you? You good? All right, so Gabriella is communicating with me through the chat. Gabriella, what is Gabriella plus 7? Can you give me an answer for that? What is Gabriella plus 7? Right, so this Gabriella, in not answering, right, she says it can't work because they're different data types. I like that. But there's a little moment when I ask that question where you kind of go, what? In your head, why is he asking that? Because you see, the thing is, that's no problem, Gabriella. Thank you very much for contributing. The question is, how can I mix Gabriella and 7? Gabriella has a name value. Gabriella is a name. Gabriella is a group of words. 7 is a number. We know what could be done with a number. A number we could add, subtract, multiply, divide, etc. We know what we could do with names. We could look for a name. We could order the name in the list, right? We could read a name. A name could be, said. But you can't mix data types like that. And the computer, just like how our brains just now had a hard time processing that information that I ask you in terms of what is Gabriella plus 7, the computer system goes through the same thing. The computer system says to itself, well, I have a set of rules with one data type and a set of rules with another data type. Okay? And these things don't match. So I can't do these operations on it. So we have some different, different categories of data types. And the categories of data type break down into 3 main categories. Okay, not Gabriella, Ayana called out some earlier. Hold on, let me just. Ayana called out some earlier, right? We have numerical data types. So this is types of data types. TY, God have mercy. Types of data types. So we have numerical data types, and there are 2 categories of numerical data types that we work with. We work with ERICL. Okay? So we have numerical data types. We have integers, and we have real numbers. And what are integers? Integers are whole numbers, positive or negative. So an integer could be 2. An integer could be -9. An integer could be 0. An integer could be 391. An integer could be -497. Whole numbers, positive or negative, right? And then we have real numbers. And real numbers are like floating point numbers. Real numbers are, the kind of numbers you see in finance and statistics. So for real numbers, you could have 9, you could have 9.0. Let me put, okay. You could have -3.2. Keep on even out my points. 3.2. You could have 0.00, 9.157, right? 8 minus 8.27. So these are numbers that we see in finance, we see in statistics. Those are parts of a number being represented. Okay, there's a point value. So, you know, there is no point value in integers. And the difference between integers and real numbers is that an integer is used for counting, you know, whereas a real number is used, as I said, in like finance and statistics. And so if I told you I had a party last Saturday and there were 8.7 people at my party last Saturday, does that make sense as a statement? No, it
No, sir.
doesn't. No. How can you have 0.7 of a person? Are you talking about like a short person, or were they missing a limb or something? If it's still one person, right? You can't have part of a person if you're counting people. But then if I say to you, on average, 25.3 people come to my parties. That makes sense. I can use real numbers in that scenario because I use my real numbers to get an average value of how many people come to my parties. So if it is that if I've thrown 150 parties and the number of people on average that come to my party is 25.3, it makes sense in that scenario. Are you all with me?
Yeah.
Yeah.
Yes, sir.
Right. So I don't have anybody lost, right? Remember, you have that hand up button that you could use. You have the chat that you could use. If something I said don't make sense, or it's not falling, you know, in a way that it's supposed to fall, then you could stop me and say, sir, one more time. Okay? All right. So we have, other than numerical data, we have character data. Character data type. And you have single characters, and then you have strings. And single characters are normally represented in single quotes like A, B, 9. So you have any single letter, numeral, or symbol at sign. Okay. Exclamation point. And even space is as character. So you have space as a character. It's an invisible character. It's a character with a bit of a superpower. So you have that whole single character. And then in terms of the character data type, you have strings, which are a collection of characters joined together. A, B, 9, at sign, exclamation mark, space. And strings are represented in double quotes. So note the quotes, typically. All right? Note the quotes. You have that single quote for single character, double quote for strings. And this here, all of this together is in one. It's all together. It's contiguous. It's flowing. It's joined together. Right? So you could have like a name. Okay, you could have like a name, Valdez. Or you could have like a join together of something. You could even have a one character string. This is still a string. It's just that there's only one character in the string. Actually, you could have a 0 character string as well. Okay? So that's something to look out for. That's something that when we get into programming, we'll be working on. So we have numerical data, we have character data, and then we have logical data type. also known as Boolean data type. And the logical or Boolean data type is simply just the values of true or false. Okay? So we have the values of true or false as our logical or Boolean data type. And that's it. That's it, our entire data set for the logical or Boolean data type. You might also see it as yes or no.
Or zeros and
Right?
ones, sir.
Yeah, on or off. Yes, 0 and 1 as well. Okay? So you, depending on your value, you get true or false. 0 or 1, yes or no, on or off. And we see that here. All right, stick with me. We have about half hour again, but I have quite a bit to go through with you. So, just stay with me. If you had to get up, go get some water, stretch your legs, do something. It's good. But I want to get through the amount that I allotted to get through today. All right. And again, I keep on stressing that if you're not quite following, you don't understand something, stop me and ask a question or put it in the chat. Right? I see, would question mark be a single character? Yeah, question mark could be a single character value. Right? So by itself, it could be a single character. Right? Even the single quote is a character value. Any character. But then all of these characters could be joined together. All of these characters could be joined together to form a string. But if a variable is declared as a single character variable, it cannot hold a string value. But a string value can hold a single character, as we've seen here. Okay, as we've seen like with this example right here. A string character, you could have a one-value string, but you cannot have a multi-valued single character. Until later on in programming, when you see that there is a special case where two characters next to each other are considered a single character. But we'll get to there in programming. But for now, just think about single character, any single letter, number, or symbol, numeral or symbol, not number, right? Any numeral, letter, or symbol. And a string is any group of single characters put together held in a single variable name. So we have logical or Boolean, the values are true or false. I'm moving forward, okay, and I want to put a nice little table inside here because, sometimes it's easier to read. It's easier to read something that's printed than Mr. Valdez Crapofoot handwriting. So data types, they're data sets. Okay, we have different data types, numeric, integer, real. We have character, string, and we have the logical. And these are the data sets, all of the numbers inside there. All right, all whole numbers, all real numbers, all letters are inside a character, all letters, numbers, and special symbols. And then we have the string values, where you have a combination of multiple characters. And logical, true or false is by itself. It is as it is. Okay? All right. So we're moving forward. I'm going to put an example in here, another example inside of here, so that we can get even further. We can get even further reinforcement for when you all have to check over these notes. All right, so we have some different examples of what is a data type in what scenario and why it is that inside of there. And we're going to go on to operators. All right. So operators. Okay. So this is just are you alive? Are you here with me? Check. Okay, if you're still with me, put up your hand. Right? Put up your hand if you're still alive. All right, so you're still with me. I'm seeing some hands going up, seeing enough hands going up to know that I still have a bit of an audience. And some people, they haven't gone running or nothing. So, right? Good, good, good. Right. Thank you. All right. So next up we have operators. So we want to talk about the operators. And we have some, we have three types of operators that we use, or three categories of operators that we use inside of inside of computers to make expressions. Okay? Because we know that we have to use these operators to be able to process the data that is inside of the computer. So what are operators? Our note here, and I'm just going to put in my handwriting operators because I find that's like a nice way to at least operators. All right. Operators are the data connectors that within expressions and equations. So they tell the computer how to process the data. So we use operators in conjunction with variables and values of different data types. Okay? So we have some different operators here. And the first set of operators that we look at are going to be mathematical operators. The first set of operators that we're going to look at are mathematical operators. So here they are. We have mathematical operators. And I, really not going to explain to you like all of these operators. I'm hoping and praying that you know how addition works, how subtraction works, how multiplication works. But we have some different types of division. And I'm going to explain this division to you. Okay? We have three types of division. And this here represents regular division and integer division in two separate ways using two separate slashes. But I'm going to let you know that when we get to programming, the division is going to be dictated by the data type. Okay, so we have what is called real number division, and we have integer division. And then we also have modulo division. So can I assume that everybody is good with addition, subtraction, and multiplication? These are the examples here, right? Yes. So Kian, I think Kian is confirming. All right. Thank you. So division, we have regular division, real number division, where we have a floating point remainder. So if say for instance I have a variable and I declare my variable int a is equal to 14, and then I say b is equal to 12, and I say c, and I say c is equal to b divided, not int, sorry. I don't want to start off with integer division. I want to start off with, right, real number division. So we have real numbers, 14, 12. I don't want 12. Let me get 14 and 6, right? So C is equal to A divided by B. What am I saying here? I'm saying that I have 14, essentially 14 divided by 6, which should give me an answer, 14 divided by 6, which should give me an answer of what? 2 and, right, 0.333 recurrent. Because the answer here should have been 6 to go into 14 2 times, and it gives a remainder of 2, and 2 over 6 is a third, which is 0.333 recurrent. Now, if I had this same expression, and the same, if I had the same expression, but I declared everything as integers, when I do this expression here, int A is equal to 14, int B is equal to 6, and we have C, which was the result. And I say C is equal to A over B, and I have 14 over 6. My answer here is going to be 2. This here is integer division. Okay? And what I get as a result is that, remember when we defined an integer, we said that an integer is what? An integer is any whole number. So what did we get? We get a whole number value that cannot hold, any floating point. And it does not matter if, say, for instance, the question was A is equal to, let's do another one, right? Again, we're doing integers. So we start off int A is equal to 19. B is equal to 4. C is equal to A divided by B. We have the data type of integer. So what we end up with is 19 divided by 4 is going to be equal, in this case, to 4. I know that if we did this as a real number, we would get 4.75 as our answer. But it does not matter that at 0.75, there is no container to hold it when we have to store the integer. So what happens is that that 4 is held, and that 0.75 gets tossed by the wayside. Okay? 4.75, we keep the 4. We keep only the whole number result. But that brings us on to the third type of division, which is modulo division. And modulo division is a division that returns the remainder amount of an operation. So let us take, again, these two integer operations here. Right? Let's take again these two integer operations here. And if it is that I'm just going to copy this here. Carry it across. All right? It's supposed to be int. And if we said A mod B as our division operation, sometimes you see mod represented as a %, or you could see it A mod B. They'll write it in both manners. What this is going to return is a value of, right, 14 mod 6 is going to return a value of 2. Where did I get that 2? That 2 is the remainder of the 6 dividing into the 14. Right? I'm going to do it for the second one. Okay, we had C is equal to 19 mod 4. The answer here is going to be 1. Sorry, not 1, but 3. My bad. Okay? Because that is the same remainder that we couldn't keep for the integer. This is 3 out of 4. Right? This is the remainder that we couldn't keep. here, right, which is 2 out of 6, which is where we got that 0.333. And we saw it, we see it when we do that old school division. Who remember doing division like this in primary school, where you have that, and you put 14 here and 6 here. And you say 6 into 14 is 2. And you say 2 by 6 is 12. 14 minus 12 is 2. And this is your remainder value. It's the same thing here. 19, 4. 4 into 19 is 4. 4 by 4 is 16. 19 minus 16 is 3. This here is your modulo result. This here is your modulo result. Are you all with me?
Yes, sir.
Yes, sir.
Okay.
I
right.
still a little confused about it. So
All right. So,
you have to put the. No, you could just explain it over, please.
no problem. So it's really and truly the same thing that we're looking at. If you look at it from the terms of the real number division as opposed to the integer and modulo division. Okay? If it is that I have as real numbers, if I have 25 divided by, let me just go onto a fresh page, okay? If I have, in terms of a real number division, I have 25 divided by 4, I'm going to get as my result is going to be 6.25 as my result. This 0.25 here is a quarter, 1 over 4, right? So you essentially have 6 and a quarter. This here is your modulo result. Because if I go for my mod division, I say 25 divided by 4, the answer for this is going to be 1. All right, so if I had 25, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5, should have chosen a smaller number, and I take out in groups of 4, right, so I'm taking out 4 at a time, I am left over with 1 here. My integer division is 25, right? This is modulo division, sorry, so I should have had the percent sign there. My integer division is 25 divided by 4. The answer here is 6. It's the same thing. Look at this, right? The groups that I have here is essentially, this is one group here, this is 2, this is 3, this is 4, this is 5, and this is 6. So you see where that modulo division comes in?
Yeah, I understand.
Right. And it works back because the divisor is 4, the result is 1, so it works back here to be 1 over 4, which is where, if we're representing it as a floating point value, we get that 0.25. Does anybody else need clarification?
No, sir.
Okay. So at this point, I just want to highlight an assistant of mine, Jamiro, who is in the session, right? You might see him answering some of your questions if you put it up on the forum. He is an assistant of mine. He's from the Netherlands. He's a friend. He is a computer science student as well. So, right, not Cape Computer Science, but he is studying computers in Europe. So, Jamiro, you want to say hi?
Hello, everyone. I'm afraid I don't have a camera at the moment, but I'll be joining the lessons and I might be answering your questions, as has been said. That was it.
All right, thanks, Jamiro. All right, so if you see him answering your questions when you put it up, or if you post a question, or if I post a question and he might give a response as to why the result is the way it is, right? Just know he's in the teachers group. Okay, so that's Jamiro. All right, so we're almost to the end of our session. Actually, it's minutes to 7. We still have a little ways to go because I wanted to talk as well about truth tables today, but I might not get it but that's okay. I will talk about it at the beginning of the next session because we're not quite done with operators just yet. And we have to get through operators. So we might just go about a few minutes after the time. Again, this is recorded. So if it is that you can't stay past 7 p.m., that's okay. You can always catch the remainder in the recording before the next class. But I always appreciate you guys staying for the interaction. Okay. All right, so we're moving on. So we spoke about our mathematical operators just then. And the last one that we have is to the power of, right, which is exponent. So this is 3 to the power of 2, which is 9. I know that you would see it represented in mathematics like something like this, 3 squared, okay? But because you are typing on a computer keyboard, you have to use a character to represent to the power of the exponent. So this is 3 to the power of 2. Okay. I'm moving on to the next set of operators, which are relational operators. We have relational operators, and we're going to still get a bit of truth tables today, but not in any fancy way, but we will start with it next week. I'm not going to compromise on what I'm doing with you, okay? Because I want you guys to know as much as possible. Right, so we have relational operators. I did not get the word relational, so I'm going to put that into here. Okay, so we have relational operators. Yes. Okay. Right. And so relational operators are simple. We have 6 relational operators. We have equal to, less than, greater than, less than or equal to, greater than or equal to, and not equal to. Relational operators are comparison operators. And unlike mathematical operators, you can also use character and string data in relational operators. Okay? So you can have a statement such as, I'm sorry, let me finish this. Relational operators compare 2 values and return a Boolean result. Whereas a mathematical operator joins 2 mathematical values and returns a mathematical result. So we have here, and we have equal to, we can have A is, and I like to put 2 equal signs because this is like what we would use in C. So we can have A is equal to B. The result of this is going to be false. A is not equal to B. The character A is A. I'm comparing it to B, but it's not the same as B, so they're not the same thing. Okay, you have less than operator, right? So you can have, again, A is less than Z, and the answer here is going to be true. And later on, I'll explain to you how this could be translated into an ASCII value, yeah, Marco, you're correct, and I will say that when we reach there. A is less than Z. A has a lesser value. A comes before Z, right, or Z. So it is true. We have greater than, right? We can have B is greater than A. That is also true. I'm just giving you all what you call it, the letter equivalence of what is shown previously. Okay, we have less than or equal to some. This is not hard maths. So in computer science, we don't write it like that. You don't write this like that. Okay, you'll get by with this you'll get by with this in computer science, but really and truly we write it like this as well, because the exclamation mark it means not. So I'm going to put this, an X there, and X there, and a little correct sign there, meaning don't do this, but you can, and you are recommended to do this. So we can have A is less than or equal to A. This is true. This is true, right? Because A, while it is not less than A, it is equal to A. There's an OR joining us here. We're going to talk about that OR value, what that OR value will do for us in terms of understanding something logically. So while it is A is not less than A is A. So it is true. Okay? The last two that we're going to do is A is greater than or equal to B. And this one is going to give us a value of false, because A is not greater than B, nor is A equal to B. So both of those are false. And then we have not equal to. If we say A is not equal to C, the answer to this is going to be true. A is unequal to C. It's not the same thing as C, right? The answer to this is true. So A and C are not the same thing. So saying A is unequal to C is a true statement. I am not the same as Jamiro. That's a true statement. However, if somebody said Jamiro is not the same as Jamiro, that's a false statement, because Jamiro is Jamiro. All right? So these are our relational or comparison operators. These are our relational or comparison operators. And then we are going on to the last thing that I will talk about today, and it will serve as an introduction to some truth tables, which are going to be the logical operators. And these logical operators, these are the ones that you really end up having a lot of fun with when you start a program, right? These can make for some interesting statements. So you have your logical operators, and we just have three logical operators, and not and or. And we have to, execute them in that order. This is the order that they get executed in when we have a statement to make, right? Not and or. So right. So we're going to take a look at a value, and what these logical operators do is that they take a Boolean value and return a Boolean result. So we take a Boolean value and we return a Boolean result. What is a Boolean value? A Boolean value is a value of true or false. So we have here a variable. If I have bool A, then the potential values of A could be 0 or it could be 1. This is a truth table here. If I have not A, then if A is 0, not A would be 1. If A is 1, not A is going to be 0. If something is not the opposite, then, you know, it is what it is, right? So if A is 0, not A is going to be the opposite of 0, which is 1. And if A is 1, then it will be the opposite of, or the you know, the opposing of 1, which is 0, because we only have 2 values in Boolean. All right? So we can say, we could create a value called a variable called going. And if I could say going is either true or false. So if I am not going, if I'm going and going is true, then not going is false. If going is false, then not going is true. If it is false that I am going, then it means that I am not going. Do you understand what I'm saying?
Yes, sir.
Yeah? Right? Yeah. Marco will bounce up those in a little bit, but I like that. Marco know it in C. All right? So again, if it is true that I am happy, then it is false that I am not happy. If it's false that I'm happy, then it's true that I am not happy. Okay? This could feel a little, you know, it takes a little getting used to sometimes, but this is what we have to practice. So in this instance, going here is the variable, just like how A is the variable here. Okay? So going is the variable, and a variable can hold values. If the variable is going and it's of the type Boolean, then the 2 values that it can hold is either true or false. And when it is true, then not going is false. And if going is false, then not going is true. I'm going to move on to AND. All right, so I'm going to move on to AND. So I have 2 variables, 2 Boolean variables, A and B. Bool A and B. So I could put them in a table, A and B, and we could have all possible combinations of A and B together, right? We could have A being 0, B being 0. A being 1, sorry, 0, B being 1. A being 1, B being 0. A being 1, B being 1. This is all possible combinations of 1 and 0. And we have A and B. We have A and B together. The rule with AND is that both have to be true for the expression to be true. So if I tell you we are going on a trip and you have to have $50 and you have to have permission from your parents, we could say that A now represents the $50. B represents permission. Do you have $50? In this case, let's take 0 as no. Right? I know that it could be the other way, but let's just assume 0 is no. Right? If you have $50, we say no. If you have permission, we say no. Then what happens? You cannot go. Negative. Right? If you have no money, but you got permission, you don't expect me to pay for you. Right? You know what? You goes nowhere. If you have the money You have more than $50, you have $1,000, but you can't show me any permission, then you cannot go anywhere. But if you have the $50 and you have the permission, then you are able to go. So only when both values are represented as true, then the expression with an AND is true. Okay? And lastly, so this is AND. This is this is not. And so lastly, we're going to talk about OR. And we're coming to the end of today's session. So, just hang in there with me. This is OR. So we're going to talk about the OR now. We have OR, we have bool, we have A, B. And we say that the rule with OR is that only one has to be true for the entire expression to be true. So we have A and B. We have A or B. We have A or B. And we can say again that we have all possible combinations of A and B together. And so we can say that if I were to tell you that you can open a bank account with your national ID card or your passport, then you only have to bring one. So you have A or B will work. So if you don't bring neither your national ID nor your passport, then you cannot open an account. If you bring only your passport, then you can open your account. If you bring only your national ID, you can open your account. If you bring both your national ID and passport, I only need one. You are providing two. So you know what? Hey, you can open an account. So in terms of the rules for this, just to drive the rules home, right? Let me see if I can, right? Yeah. With the rules here, indicate that we have the not operator essentially inverts the value of a logical variable, right? So it inverts a logical variable. The AND operator joins two variables, and it's only true. It is only true if both variables are true. That's like the $50 with the permission. That's what I said to you. And you know, you can't just bring one, you have to come with both. And then the last thing is the OR variable, where is only true if one variable is true. Right? Let me put if at least one variable. Right? So if at least, and I'm underlining that, if at least one variable is true. So both could be true or one could be true. As long as you have one, then the OR operator will give you the expression true. All right? This is where I'm going to end today. I am going to resume next week with some truth tables, we're going to go into this a little more because I feel like it's really important for us to understand truth tables and logical expressions, because a lot of programming and programming expression is based upon this here. So what did we do today? Just a quick recap. We went through the syllabus. We didn't take a look at the SBA. Maybe I could do that with you all sometime later down. I promise to at least talk about that at some point, right? We started by looking at the problem solving process. Okay. We talked about variables and constants. We took a look at data types. We took a look at operators. We didn't talk about the operators according to the hierarchy. I will do that next class, next week. And we will also next week set up some values and evaluate expressions. Okay? So I think that we are at a good place here. I'm going to stop at this point. I'm going to stop recording as well. And then I'm going to make myself free for about 5 minutes to talk to anybody, unless anybody have any questions they want to ask now while we are on the recording that they feel might be useful. And then I'm going to exit the recording. Any questions at this point? No.
No, sir.
All right, thank you. All right, so that's officially our end here. All right, so we are going to stop recording. I'm going to put this recording up when it becomes available on the Google Classroom. I'm going to put these notes that we've created here up today as well. And let me just, right, I'll have to just take down a note of what I'm going to have to do next week. Next week, we're going to continue truth tables and talk about hierarchy, right? All right, so that's it. Goodbye, everyone. I will see you all next week. I'll see you all in the Google Classroom. I hope this was useful. Yeah. Have a good night, Marco. Right.
Bye.
Bye-bye,
Enjoy your
Ayana.
Saturday.
You too.
Bye, sir.
Bye-bye. Bye-bye.
Bye.
Bye. God bless.
Excuse I could be added to the Google Classroom, please.
Yeah, I can give you the code for the Google Classroom. All you have to do is go to classroom.google.com. I'll put the code up on the screen, okay? So hold on a second. Just hold 1 second, right? I'll put the code up on the screen. You write this down, and all you do is, yeah, Jamiro just shared the code in the chat as well. So once you get it,
thanks,
you're good to go. Right? It's taking a little while to come up. Right. Yeah, Jamiro shared it in the chat.
Okay, thanks, sir.
All right, then, Aidan.